To introduce myself, I'm Joe Walsh. I'm the CEO of Intrinsim and also the CEO of the Assess Initiative. I've been involved in the CAD/CAM CA industry for about 40 years. And Intrinsim works very closely with software vendors to connect worldwide technology and business. And the Assess Initiative works to foster and enable the simulation revolution for broader use of and benefit of simulation. So what we're going to talk about today is why is 2020 the right time for generative design, and we're going to introduce the concept that we refer to at Intrinsim as a vision for generative design. I'm not going to talk about any particular product capabilities. I think Chris and the team from Altair are going to cover that. What I'm going to talk about are concepts and justifications, reasons, potentials, benefits of generative design in general for anybody who's looking to leverage the capability. So first, we're going to start off with what is generative design. And the Assess Initiative actually worked with several software vendors to come up with a common definition of generative design so that we can get out of everyone having a different definition. And that definition says generative design is the use of algorithmic methods to generate feasible designs or outcomes from a set of performance objectives, performance constraints, and design space for specified use cases. The Assess Initiative goes on and actually describes that those objectives and constraints can include things from multiple areas, including performance, weight, mass, manufacturing, usability, aesthetics, ergonomics, and costs. I think ergonomics and aesthetics are a challenge yet to figure out how to quantify, but we see the whole aspect of generative design growing over time. So what's really important about the definition is generative design is not a particular algorithm or an optimization technology, but instead may leverage one or more optimization technologies and algorithms along with artificial intelligence to create or drive viable designs for outcomes for a specific design scenario. So what we're really going back to as a definition is the ability to algorithmically create designs given a set of criteria and a design scenario. What this introduces is the possibility of a paradigm shift. This means that designs are generated by algorithms, so it enables exploration of a broader range of concepts that an individual would never be able to have time to pursue. It enables generation of effective designs for different or multiple manufacturing processes. So it's actually possible to look at choosing the manufacturing process as part of the generative design design space. It also enables significantly increased design innovation and performance-driven design very early in the design process, which dramatically reduces the design analysis cycles. This enables exploration of a broader range of concepts with dramatically different designs than we've worked with in the past, no longer minor tweaks of what was there before. And so it also enables generation of effective designs for different, well, the same slide. So these things will reduce time, reduce cost, reduce weight, increase quality, and improve innovation, and therefore, by doing those things, improve competitiveness. So the Assess Initiative, and with working in collaboration with Intrinsim, have actually come up with a set of key capabilities that are necessary for software for general applicability. These include, and we're going to go through these in detail, so I won't cover these, but there's 11 capability areas. We've also come up with the concept of a capabilities assessment model. And we've also indicated that if you're going to enable a paradigm shift, you have to actually consider organization and cultural changes. Due to time constraints, I'm not going to discuss the organizational and cultural changes. That would be a webinar in and of itself and then some. But let's acknowledge that they're there because some of the roles, if you implement generative design in a significant way, the roles of who's doing simulation and who's using it at what time will be changing, so it needs to be taken into consideration. Who runs the generative design, for instance? So let's look through the different key capability areas that the software solutions need to be able to provide, and that you need to consider as requirements and what level of requirements your application needs. So the first item is handling all appropriate objectives and constraints. Basically, the designer or design engineer who's doing conceptual design today is accounting for a variety of objectives and constraints without explicitly defining them to any software. To be able to replace that effort with generative design, we have to be able to handle the same range of constraints and objectives that the current designs are working under. For that to work for a paradigm shift in the industry, that means it has to cover a broad range of these. To work for any particular application, it only has to cover those that are related to that application. But different constraint combinations and objective combinations will actually generate different designs. The other issue that we have to deal with is that of handling multiple operational or load conditions. Very rarely do we define anything that is a single load case. So the generative design needs to intelligently work with multiple load conditions. It needs to be smarter than just adding in the material that any load case wanted, because that would be suboptimal. It has to actually intelligently manage the results so that it accounts for the multiple load cases. We also have to handle all of the necessary physics to define the particular problem. To be broadly deployable, it needs to cover a very broad range of physics. When looking at generative design for your application, you need to understand which physics are necessary and make sure that the ones that you need are actually covered by the generative design solution you're looking at. Because similar to, if you cannot cover load cases or physics, then the designs that you're generating are at best ideas to use to base things off of, and they're not directly usable as a design unless it covers the full range of what your scenario requires. The other key item is to enable a paradigm shift is it has to handle multiple manufacturing processes. There's a big, everyone's enamored with additive manufacturing, and that opens up tremendous capabilities and options and innovation, but a significant amount of manufacturing today is still done with subtractive processes. So we're really looking for things where the person running the generative design can choose which manufacturing processes are of interest and can actually compare different designs from different manufacturing processes. That would be the objective, to determine, is there really a benefit for switching from a subtractive process to an additive, or is it actually still cheaper to make this with additive manufacturing? And that brings up the other objective, which is we need to actually handle, to be really truly effective and enable a paradigm shift, cost has to be accounted for in some manner. Because the actual number of parts that you're making influences the cost, and we really aren't interested in generating beautiful, very complicated designs that we can't build because they're too expensive. So the ability to account for cost as a filter is a really important requirement to enable significant use of generative design, because that way you can compare the effectiveness of the actual manufacturing cost as part of the process. We're also looking at handling generative design in an assembly or system context. What this comes down to is actually working at a component level and making sure that the load, you have the appropriate loads on the component that are generated from the system. Causes a limitation that we require a level of expertise to make sure that the loads have been transferred correctly. So you really want to be able to load at an assembly level and have the assembly work the loads down to the component that you're working on. You also may want to work on doing a generative design of multiple components at once, because the load distribution will be a function of the stiffness or conductivity or whatever the appropriate transport mechanism is for the physics that you're looking at. So it's very important to be able to enable generative design at the assembly context so that you can load at the assembly level where it's more clearly understood what the input loadings are, and so you could actually do generative design on multiple components in the assembly. The trick hidden there is that I don't describe in detail here is to do this well, you have to actually account for the connections and the load transfers between every component. And I believe that the Altair guys have some excellent tools to do that. The other key thing, if we're going to enable a paradigm shift with generative design, is the software needs to enable informed, comprehensive, and efficient exploration of the viable design alternatives. So you should be able to look at a much wider range of design options than a human designer should be able to do, and you should have efficient and effective tools to explore all of the viable design options with either single or multiple design objectives, so that you can actually explore and look at trade-offs from different constraints and different objectives. So we need to provide design explorations that's broader and more comprehensive than it's possible to do without generative design. The idea is to explore a broader space more efficiently. And that brings up the next key requirement and capability is efficient selection. It doesn't do us any good to generate hundreds or thousands of possible design options from generative design. We need to find a way to work that down to a meaningful set, even though we may have described the problem such that there really are hundreds and thousands of viable designs. We need to include things like artificial intelligence or other approaches and filters so we can get down to a reasonable set of designs for the user to consider. Moving to thousands of designs does not save time, that just moves the effort to a different type of activity. So therefore there needs to be the ability to either control the number of designs created or bring them down to the meaningful design so that quicker decisions can be made. And one of the key things is we expect that generative design is going to be used in the early stages, the concept design stages or early stages of design, to be really effective. In order to do that, further validation, further detailed design, further analysis is still required. So therefore, there needs to be an efficient and effective transformation to detailed design and analysis. The ultimate goal is that transition is fully automated, so that not only the geometry comes along, but all of the loads, boundary conditions, the entire design scenario that was used for the generative design maps to the later stage validation and is capable for analysis at a standard finite element software solution. So the idea is to enable that full transition, and the ultimate goal is for that transition to be completely and fully automated. The other thing that's key and important is if we're going to move this earlier in the design process, then the use of generative design means the target user is not the simulation expert, but the engineers and designers responsible for early design concepts and for maturation of the design. So therefore, it has to be well integrated into the designer's workflow or enable a workflow that's suitable for them so that these users actually have access to the software and are knowledgeable how to use it and can leverage the data as an integral part of their design process. Excuse me. It also needs to be broadly accessible. So that it needs to be made broadly accessible for all of those who might be involved in the paradigm shift. So that means flexible licensing, that means easy access, easy setup. So it needs to be available for a wide range of people. So that covers very quickly, probably a little quicker than I intended at first, but very quickly it covers what are the key capability areas that are required to enable a paradigm shift. So that in that process, IntrinSim and Assess Initiative have also turned around. Once the capability areas have been developed, we actually developed a capability assessment model. There is no generative design provider who meets the desired state of capabilities across the full range of the required capabilities for all potential applications. Either they do everything that's required for a set of applications, or they do much of the things, or they do it at a reasonable level, a functional level, but they don't maybe capture everything. And I'm not going to go into details as to where Altair fits in this. They're going to talk to you about their software. What we are saying instead is there is no solution that says, here's generative design that works across all of the capabilities at a perfect, comprehensive level for all of the potential applications. So that's why we developed a capability assessment models so that we can determine where capabilities are and where requirements are. So many applications can be addressed today by the current workflows that are available. And you'll see great examples of that today. So this capability design assessment model enables the assessment of the suitability based on detailed criteria for each capability area. So there's a simple example of handling multiple load conditions with different assessment levels of limited, basic, functional, advanced, and comprehensive, and detailed criteria. And there's another example on the right showing just the limited and basic capabilities required, the criteria required to achieve those for handling all appropriate objectives and conditions. Once the capability model has been created and once it's been assessed, that can be used to determine requirements for a particular design scenario. So if you're interested in using generative design for a particular design scenario, you can look through all of the key capability areas, checking the physics capabilities, checking the multiple load conditions, how does it match against all of these criteria, and then you can do the same assessment or have it done for you that indicates how does a particular workflow handle that, and then it's possible for a particular application as shown on the right, looking at two applications, it's possible for all 11 of these areas to determine the suitability index, and you end up with 3 states. One, it's clearly suitable for your application, the generative design workflow, because the mean and the minimum are acceptable. The next state is it's possibly suitable and needs investigation, which would be application 1 here, suitability. The mean suitability index is greater than 1, but there are some that are not suitable and you need to investigate, are they going to give you a problem? And then there's the third classification, which is clearly not suitable, which basically says the mean and the minimum the mean is less than the desired 1.0 suitability index. So the suitability index really is determined for each capability criteria by dividing the capability rating by the requirement rating. So it's really a quite straightforward sort of process. So the capability assessment model actually includes for the criteria a way of quantifying everything into explicit numbers so that very quickly can be used to determine whether or not Altair's solution, for instance, is suitable for an application 1, but maybe not suitable for application 2 because you want to use a manufacturing process that's currently not supported by the constraints. And so that those are the sort of things that you can consider with the capability assessment model. So why is 2020 the right time? Going back, so now we've gone through the vision. So the vision of generative design is that the paradigm shift is possible. But to enable that paradigm shift, we're going to need to have the ability to assess, we need to have the ability to assess the key capabilities in these 11 key areas. So why is 2020 the right time? 1, when it is suitable, generative design can enable a paradigm shift with major benefits. And 2, there is a capability assessment model that is available to determine suitability. So it's no longer a question. You can actually do some assessment ahead of time and then verify that with actually testing the software. And again, so when it does work and it is suitable, it will dramatically reduce time, cost, weight, quality, innovation, and it will improve quality, improve innovation, and improve competitiveness. So the business advantages are there to take the time and effort. The question is when it is suitable, and that's why a lot of effort was put in by Intrinsim and Assess to develop the suitability index in the capability assessment model. Thank you. There's my contact information, and there's further information where you can get a document on a vision for generative design, with much more detail. And there's also a white paper from the Assess Initiative on understanding a generative design enabled design process paradigm shift.